So I just transcribed my voltages onto the circuit. So the polarities were already written in. So I just plug in the numbers right next to the component and consider. So I don't write plus or minus on my numbers because the polarity of the components takes care of that. So if I happen to have, like if I for some reason had a negative number, I wouldn't write it negative again. I would just use the plus and minus on the component, the polarities, and which direction I was looking or how I was measuring it to determine the plus or minus. Okay, so what I'm going to do is I'm going to come in from this node and then follow this loop to create a voltage loop to solve for my unknown. And I'm going to use the polarity shown to do that. Okay, so first things first, I'm going to start right here at this point D, go up through that unknown voltage, my meter, and so I'll show you what I'm talking about. So as always, Kirchhoff says 0 equals, and I'm going to use my lead placement as I described to determine, I'm going to hit that negative lead first. So negative VCD, right? Plus, I'm hitting the plus side of R3, so plus VR3. And then I'm hitting the negative side of the 16 volt supply, so minus 16 volts. And then plus VR4. Alright, so my unknown that I'm solving for, is VCD, so I'll just solve for that right now. So basically that becomes somewhat easy, so I could just say VCD, add it to both sides, equals, VR3 plus VR4 minus 16 volts. Alright, and so like I said, if I get a negative result, if I put my leads just like that, as if I was measuring VCD, double subscript notation, if I get a negative number, it tells me that my polarity from C to D is in fact negative, and I would see that on my meter if I was to measure it. So let's plug in some numbers and find out. So VCD equals, so VR3 I got 2.694 volts. VR4 was 3.673 volts minus 16 volts. So VCD equals, whoops, let's get the calculator in on this. Whoops, I went to sleep. There we go. There's the calculator, so clear that out. Alright, so now I happen to have these things saved. Now, whether or not you save all your history in your calculator, it'll reduce a little rounding. I'm not sure if I care so much right now, but let's just, since I have it, plus that plus, and then minus 16. And I am getting a negative 9.633 volts. So if I was to build this circuit and put my voltmeter just exactly the way I've shown it on VCD, C positive, red negative, I would measure a negative 9.633 volts. Okay, so now I can confirm using this other loop I should get exactly the same reading, or the exact same value. So I'll just do it right down here. So I'll start here as I always do. So Kirchhoff says 0 equals minus 20 volts plus VR1 plus VR2 plus VCD. I hit that positive lead first, and then I'm coming down through the meter, and then I'm going to hit plus R5 plus VR6. All right. So let's see. What I'm solving for VCD, so I need to basically subtract, or I'm going to add 20 to both sides and subtract all my voltages to both sides. So essentially I'm going to get VCD equals plus 20 volts minus VR1 minus VR2 minus VR5 minus VR6. Alright, so let's just plug in values and solve. Alright, minus 2.694 volts minus 3.184 volts minus 5.388 volts minus 18.37 volts. So let's see what VCD equals. VCD equals, get the calculator back here. Alright, so get some room to get those numbers in here. So let's clear out my old one. So 20 minus, I'll just jump up there and get those numbers. So I had, first off, this one minus 3.184 minus 5.388 and minus 18.37. Alright, now look at this. Got the exact same number. Minus 9.633 volts. So what that tells us is that right here, I'm on my meter, I have a minus 9.633 volts. So if I come in here, let's just replace this stuff here. Okay, so I'll come in here with my diode again. All right, and it was facing like this. All right, and so my polarity is going to be like this, and the voltage that it sees is going to be 9.633 volts. All right, and if you remember, the rating VZ was 9 volts. Okay, so that means that I've basically I'm reverse biased. Okay, so my result, the VCD, right, is greater than VZ. Okay, and therefore V of D1 equals 9 volts. So therefore VCD, now remember, it's negative 9 volts. So my diode has just reacted, and it will not be minus 9.633 anymore. It's going to start allowing current through, change its internal resistance, and hold the 9 volts, and it will be 9 volts. If you were to measure it from C to D, you would see minus 9 volts right there on your DMM. And so all of these voltages that we've just found are now changed, which is part of the reason that everyone loves this circuit, and part of the reason that it's good to understand how diodes will affect your circuit, or how they will react or behave in your circuit. So all good stuff.